You know, there's a group of materials so incredibly common, you are probably touching at least 5 of them right now without even realizing it. They are the hidden backbone of our entire modern world, and believe me, their story is absolutely fascinating.
So let's start with a little puzzle. You've got these 3 things: a non-stick pan from your kitchen, a nylon jacket you might wear on a rainy day, and a car tire. On the surface, they seem completely unrelated, right? I mean, different textures, different jobs, different properties altogether, but they all share a deep, fundamental chemical secret.
And that secret is they're all made of polymers. That one word connects this incredible, mind-boggling range of materials, from the softest fabrics you can imagine to the most durable plastics ever made. They are truly the master shapeshifters of the material world.
Okay, so to really get what makes these materials so special, we need to peel back the layers and look at their basic building blocks. These are the simple ideas that come together to create some seriously complex structures.
The word polymer itself actually gives us a huge clue. It comes from the Greek for many parts, and that's exactly what a polymer is. A massive molecule, basically a super long chain, built from many repeating parts all linked together over and over again.
And if the polymer is the final giant structure, what are those many parts? Well, they're called monomers. The best way to think of a monomer is like a single Lego brick. By itself, it's just one small piece, but when you start snapping thousands of them together, you can build something incredible.
In the process of linking all those monomer bricks together, that's called polymerization. This is the chemical reaction, the moment of creation, where these simple, tiny molecules are chemically bonded into a long, repeating chain, creating a brand new material with totally new properties.
So we know we need to link these monomers together, but how does that actually happen? Well, it turns out that chemists have basically 2 master recipes for building a polymer.
On one side, you've got addition polymerization. This is a really clean connection. The monomers just add to the chain, one after another, and every single atom from the monomer ends up in the final polymer. Nothing is wasted. Then, on the other side, you have condensation polymerization. In this recipe, when the monomers join up, a tiny molecule, like water, gets kicked out. This choice of recipe is absolutely crucial. It's how chemists get to control the final properties of the material they're making.
Let's make this a little more concrete by zooming in on one specific type of addition polymerization. It's called free radical polymerization, and it is a fantastic example of a chain reaction in action.
It all happens in 3 quick steps. First up is initiation. A special molecule creates a spark, a super reactive little particle called a free radical. Next is propagation. That spark hits a monomer, which makes it reactive, and then that one hits another, and so on, setting off a chain reaction that grows the polymer chain incredibly fast. And finally, termination. The whole reaction stops when 2 of these growing chains bump into each other and combine. And that's it. You've made a polymer.
All right, enough of the theory. Let's see how these chemical recipes actually build the materials you might recognize. It's time to meet the polymer all-stars that we use every single day.
First up, Teflon. Hey, remember that nonstick pan from our opening question? Well, this is the hero behind it. Its scientific name is a real mouthful, polytetrafluoroethylene, or just PTFE for short.
Its monomer is tetrafluoroethylene, and it's made using addition polymerization. That's the clean, direct connection method we just talked about. This unique structure is what gives it those incredibly slippery, non-stick properties, perfect for making sure your breakfast doesn't become a mess.
Next on our list is nylon 6,6. If you're wearing a jacket or you've got a backpack nearby, there's a really good chance this polymer is involved.
Now, unlike Teflon, nylon 6,6 is a bit different. For starters, it's made from 2 different monomers, and it's a condensation polymer. This means it uses that other recipe, the one where a tiny water molecule is released every time a link in the chain is formed. This process is what creates that super strong, silky, and durable fiber.
Okay, let's look at a true pioneer, Bakelite. This was one of the very first synthetic plastics ever created. An absolutely revolutionary material from the early 20th century.
Bakelite is also a condensation polymer, but it has a little trick up its sleeve. It forms this special cross-linked network structure. This makes it incredibly hard and heat-resistant, which is why it was perfect for everything from old-school radio casings and combs to electrical switches. This stuff really kicked off the age of plastics.
You know, it's easy to think all polymers are man-made plastics, but that is not the whole story. Nature is the original polymer chemist. Wood and cotton? They're made of a polymer called cellulose.
and natural rubber comes straight from trees. We humans have simply learned how to mimic and modify these amazing natural structures to create our own synthetic versions.
And that brings us to a really crucial modern-day issue. Many of the synthetic polymers we've created are incredibly durable. So durable, in fact, that they just don't break down in the environment. And this has led to a massive pollution problem. So, what's the solution?
Well, the answer might just lie in a new class of materials: biodegradable polymers. These are cleverly designed polymers that can be broken down naturally by microorganisms. They're literally designed to do their job and then just gracefully disappear.
And their uses go way beyond just better packaging. In medicine, biodegradable polymers are nothing short of revolutionary. We're talking about surgical stitches that dissolve on their own as a wound heals, orthopedic devices that support a broken bone and then just disappear, and even systems for precisely controlling the release of drugs inside your body. This is seriously cutting-edge science.
This really leaves us with a final thought. Polymers have completely shaped our world, giving us these incredible materials that have defined modern life. The challenge now is to keep that innovation going, to create new materials that are not just useful, but also sustainable. The story of the polymer is far from over, and the next chapter is being written as we speak.